Mathematics is more than just numbers. It is a universal tool, a framework that transcends cultures, languages, and even time itself. It is the language of the universe, a code that describes the cosmos in its purest form. A language that helps us, understand the world around us. It allows us to decode the mysteries of nature and make sense of the chaos. From the smallest atom to the largest galaxy, math is everywhere. It connects the microcosm to the macrocosm, revealing patterns and structures that would otherwise remain hidden. It is the key to unlocking the secrets of nature, guiding us in our quest to understand the laws that govern our existence. Imagine a world without numbers, a world where we couldn't quantify, compare, or calculate. We wouldn't be able to count, measure, or build. The structures we rely on, the tools we use, would cease to exist. Trade, construction, and even art would be impossible. Civilization as we know it would not have taken shape. Our understanding of the universe would be limited to what we could see and touch. The vast expanse of knowledge we now possess would remain out of reach. Math has been essential to the development of human civilization. It has shaped our history, from the earliest records of counting to the most advanced technologies of today. From the earliest farmers planting crops using basic arithmetic to divide their harvests, to the engineers designing rockets that take us beyond our planet, math has been the driving force behind human progress. It has always been our constant companion, a silent partner in every discovery, every invention, and every leap forward. It is the foundation upon which we have built our knowledge and our world. Mathematics is not just a subject, it is the very essence of understanding, innovation, and progress. Our journey through the history of mathematics begins in ancient Mesopotamia, a land of remarkable innovation and profound discoveries. Nestled between the Tigris and Euphrates rivers, this region was home to one of the earliest known civilizations. Known as the cradle of civilization, Mesopotamia was where humans first mastered the art of agriculture, transforming wild landscapes into fertile fields. This mastery laid the foundation for settled life, enabling the growth of cities and the birth of complex societies. It was also here that the first writing systems emerged, etched onto clay tablets, preserving knowledge for generations. Among these early innovations, mathematics began to take shape. The Mesopotamians used mathematics not just for trade and construction, but also to solve practical problems in their daily lives. Their clay tablets reveal calculations and formulas that hint at a deep understanding of numbers and their applications. The Babylonians, who thrived in Mesopotamia over 4,000 years ago, were true pioneers in this field. They developed advanced mathematical techniques that were far ahead of their time. Their system of mathematics was based on the number 60, a base 60 system known as sexagesimal. This unique approach allowed them to perform complex calculations with remarkable precision. The influence of this system endures to this day. We see it in the way we measure time. 60 seconds in a minute, 60 minutes in an hour, and in geometry, where a circle is divided into 360 degrees. This legacy is a testament to their ingenuity, but the Babylonians didn't stop at mathematics. They were also skilled astronomers, using their numerical expertise to unlock the secrets of the heavens. By carefully observing the movements of stars and planets, they developed sophisticated methods to track celestial patterns. Their work was not just for curiosity. It had practical applications in agriculture, navigation, and even religious rituals. These early astronomers laid the groundwork for the science of astronomy, blending mathematics and observation to create a legacy that continues to inspire us today. As the Babylonian civilization flourished in Mesopotamia, another great civilization was emerging along the banks of the Nile River, ancient Egypt. The Egyptians, like the Babylonians, developed their own unique system of mathematics. Egyptian mathematics was primarily driven by practical needs. They used math to survey land, construct buildings, and manage resources. The massive pyramids and temples that still stand today are a testament to their advanced understanding of geometry and engineering. Perhaps the most famous example of Egyptian mathematics is the Rhind Papyrus, a document dating back to around 1650 BC. This papyrus contains a collection of mathematical problems and solutions, offering us a glimpse into the mathematical minds of these ancient people. From the fertile valleys of the Nile, we travel to the shores of the Aegean Sea, where ancient Greece gave birth to a new era of mathematics. The Greeks transformed mathematics from a tool for practical problem-solving into an abstract and rigorous discipline. Greek mathematicians such as Thales, Pythagoras, and Euclid developed the concept of mathematical proof. They believed that mathematical truths could be established not just through observation or measurement, but through logical reasoning and deduction. Euclid, who lived around 300 BC, is considered the father of geometry. His book, Elements, presented a systematic and logical treatment of geometry that became the standard textbook for centuries. Section 5. The Eastern Masters of Numbers. While the Greeks were busy laying the groundwork for geometry, mathematicians in India and China were making remarkable strides in algebra, number theory, and even early forms of calculus. These ancient scholars were not just solving equations, they were shaping the very foundation of mathematics. Indian mathematicians, for instance, developed the concept of zero. This wasn't just a placeholder or a symbol, it was a groundbreaking idea that redefined how numbers were understood and used. I mean, just think about it, zero, a number that represents nothing, yet holds infinite potential. It's the cornerstone of modern mathematics, enabling everything from basic arithmetic to advanced computational algorithms. This revolutionary idea would go on to profoundly shape the development of mathematics as we know it, but that's not all. Indian scholars also delved into trigonometry, exploring the relationships between angles and sides of triangles. They developed early trigonometric functions and concepts that would later influence mathematical studies across the globe. Trigonometry, as you might know, is the branch of mathematics that explores the relationships between angles and the sides of triangles. It's a field that has applications in everything from astronomy to engineering. Now, on the other hand, Chinese mathematicians were known for their fascinating work on magic squares and something called the Chinese remainder theorem. These were not just intellectual exercises, they were practical tools for solving real-world problems. And here's the interesting part. These concepts, which initially might have seemed like just recreational mathematics, eventually found important applications in fields like cryptography, coding theory, and even modern computer science. It's incredible how ideas from centuries ago continue to influence our world today. Pretty amazing, isn't it? The Eastern Masters of Numbers truly left an indelible mark on the history of mathematics, shaping the way we understand and interact with the world around us. For centuries, mathematics continued to evolve, with new discoveries and breakthroughs building upon the foundations laid by earlier civilizations. Then in the 17th century, a revolution occurred that would forever change the landscape of mathematics: the invention of calculus. Two brilliant minds, Sir Isaac Newton and Gottfried Wilhelm Leibniz, independently developed calculus, a new branch of mathematics that deals with continuous change. Calculus provided mathematicians with powerful tools to describe and analyze motion, curves, and other phenomena involving change. The invention of calculus marked a turning point in the history of mathematics. It opened up new avenues of exploration and laid the groundwork for the development of modern physics, engineering, and other scientific disciplines. While calculus revolutionized our understanding of the continuous, another branch of mathematics, number theory, delved into the fascinating world of whole numbers. Prime numbers, those numbers greater than one that are only divisible by one in themselves, have captivated mathematicians for centuries. Despite their simple definition, prime numbers exhibit complex and intriguing patterns that continue to puzzle mathematicians today. From ancient Greek mathematicians like Euclid to modern-day mathematicians like Andrew Wiles, who proved Fermat's last theorem, the study of prime numbers has driven innovation and discovery in mathematics. Today, mathematics continues to be an essential tool in our understanding of the world. From the smallest subatomic particles to the vast expanse of the cosmos, math is the language we use to describe and understand the universe. Mathematics is the foundation of modern technology. Computers, smartphones, the internet, all rely on sophisticated mathematical algorithms and models. Medical imaging, weather forecasting, and financial modeling are just a few examples of how math is used to solve real-world problems. As we stand at the forefront of scientific and technological advancement, one thing is clear: the journey of mathematics is far from over. New discoveries and breakthroughs continue to push the boundaries of our mathematical knowledge. From the mysterious world of quantum mechanics to the vast realm of artificial intelligence, math will undoubtedly play a crucial role in shaping the future. The story of mathematics is a story of human curiosity, ingenuity, and the relentless pursuit of knowledge. It is a story that continues to unfold, revealing new wonders and inspiring future generations to explore the infinite possibilities of the mathematical universe.